first one. The very first thing I want you to do on your paper is write out the formula. What is the formula? Ax squared
Something like that.
plus bx.
Equals y? See?
It's y equals ax2 plus bx plus c. Okay? So we need to put it in this format, right? Someone say yes.
Yep.
So we're going to subtract this from this side, correct?
Yes, sir.
And then we're going to organize it. It's going to cancel out. I should have done that. The 2x2 goes first, then the 3x, and then the c.
We done?
Not yet. Now write A, B, C, and put the numbers in. Yes?
Why don't we put the ax squared? How come we don't do that full thing?
We're not solving it because we're concerned just about the coefficient. That's actually a good question.
Is 3x gonna?
Oh, we don't write the x, it's just the number in front of it.
Oh, okay.
Okay, any questions on what we did?
Oh, yeah.
So, do we know this is quadratic? Without even looking at it, do we know this is quadratic?
Yeah.
Yes, we know it's quadratic. When you have an exponent of 2, we have a value of b, we have a value of c, it's quadratic. What happens if we didn't have this negative 1? What would happen?
Linear?
No. What happens if we didn't have this? Does it matter?
Yeah.
It doesn't matter. C can be 0. X can be 0. That's fine. Okay? You just can't have all three of them 0, right? You wouldn't have anything. There'd be no value there. Okay, could we actually graph and solve this out?
Yeah.
We could. If we were going to set up a table, how would we do this? What would our x be? What would we start with?
-2.
Very good. And
No, 3.
negative 1, 0, 1. Okay, so we're just going to do one of them. This would be our formula, right?
Yes.
So we write this. We would write this and then solve it, right? We do substitution. So we take -2, -2, right? And then solve it so we can get our y. So let's go ahead and do that real quick. Negative by negative is in parentheses, right?
Positive.
Yeah, so that's just going to be 4 times -2, right? I'm just going to take care of this. This is -6, -1, right? Any questions? Okay. Finish order of operations. -8, -6, -1, which is what? -15. Okay, so we'd have an x and y, right? And we could go graph it out. Now I'm not going to go all the way through it because we already know it's quadratic. We already know we're going to have a second common difference. We know it's going to curve around. We know this because of this, because it fits within this form. Good? Okay. So you're going to have questions like this on the test. You need to get them in this format, okay? And you are going to have some that you're going to have to go through all of this and graph them out, okay? Now we'll get to the parabola, the vertex, and the maximum and minimums and all that sort of stuff as we go through some of these problems. Yes?
I know I'm going to fast, but what if it's like number 4 is all laid out?
Is number 4 laid out?
No, but like I know it's not laid out, but I'm saying.
What's wrong? What's wrong with that one? Look at the order it's in.
The 6x squared should be in front, negative or positive 1 should be in back.
Yes.
Squared, it should be
Yeah, that's correct. Let's go ahead and do that.
But I'm just,
Now we could do something with that, right?
yeah.
Yeah.
I'm just saying, what if it's already written out for us, we just gotta do the rest of the work.
Sometimes you're going to have something like this, and you have to put it in this form. If you said it was done, you'd be wrong, right? Because it's not in the right order. Okay? And then, if this problem says to graph it, you got to use -2, -1, 0, 1, and 2. Plug it in the formula, solve it to get your y's, okay? Then do common difference, second common difference, graph it out. That's basically what all this is. Identify the vertex, identify maximum and minimums. What is the maximum or minimums?
A maximum is when it's going
Down.
but at the same time it's like down.
Okay, good. And what letter is it in the ordered pair? Well, you have two things in ordered pair, right? X and Y. Which one would it be?
X.
No, it's the Y. Okay, good job. All right, so let's look at this. Do we have a common difference here?
No. Like, yeah.
Plus 1.
Okay, +1. Let's start to work on this one. What's 39 and 18?
21.
What is it?
Negative 21.
-21?
Mm-hmm.
Okay, and what about 18 to 3?
50.
Negative, right?
Yeah.
Okay, what about 3 to
Negative.
-6?
Negative 9.
It's a Christmas miracle. It's how much?
Negative 9.
Okay, and then 6 to -9?
Negative 3.
Okay. All right, let's look at these now. 21 to 15?
Plus 6.
And,
Plus 6. Plus 6.
okay, so is it quadratic?
Yeah.
Yep. Okay, so first common difference doesn't matter, but second common difference does. It has to match, right? It has to be the same number? Someone say yes?
Yes, sir.
Okay, let's go ahead and graph this out. So we're going to be 39 to 9. I'm going to show you a quick way to do this. We're going to do these by 10. 10, 20, 30, 40, and then -10, -20. And these are going, oh, these are all just negative. So 0, 1, 2, 3, and 4. -4, right? Okay. So if I'm gonna go graph this, oh boy, that one's kind of tough, right? Because it's kind of tight and then it goes really, really big. Let's do it anyway. So we're gonna be -4 and 39. So we're gonna be right here. We're gonna be clear up here, right? That's gonna be a first spot. Let me get a different color. And then our next one is going to be 3 and 18. Right about there. And then -2 and 3. Right about there. And then -1 and 6. So it's going back up. And then 0, 0, and 9. So we can kind of see it's curving back up, right? Even though this graph is not to scale. So where does it start to curve back up? If you're -4, -3, 2, -1, 0. Oh, wow, I think we have to keep going. No, because we're 0 and 9. We actually know what it is because it's gonna stop at this point and then start going up, right? We're gonna be 1, 2, and 3. We're still going to be +1, so it's going to curve right here, right? So that's going to be our midpoint. So if our ordered pair is 0, -9 in the vertex, is this minimum or maximum?
Maximum.
Because it's going what direction?
Down.
Isn't it going up?
Also, would it be minimum?
Would it be minimum or maximum? Which one is it?
Minimum.
Minimum.
Yeah.
Okay, and what would the minimum be? -9? It's always the y, right?
Oh,
Okay, any questions on this? You won't have one that will spread out that far. It'll be in proportion to the graph. So when you go to graph it out, you're able to see it. Okay, let's start to work on this one. If we have a problem like that, how are we going to start that?
you graph them out.
Table.
Table, very good. Adrian, you could have graphed it, but isn't it faster to do the table?
Yeah.
Okay, let's go ahead and do that. X, Y. We already know there's a common difference here, right? Someone say yes?
Yes.
+1. Okay, so we know the X. Now we're going to do the Y. Does anyone see it by chance?
Yes. Plus 2.
Okay. So plus 2. Do we have a common difference all the way across? What's 19 to 21? Make sure the ringer's off, please.
It's 2.
How much?
2.
And 21 to 23?
2.
Can someone tell me what this line is before we go any further?
Linear.
It's linear. Very good. Why is it linear?
Because it's a regular.
Common difference of both sides. Is there anything else we need to do in this problem? No. We can't identify a vertex, a parabola. We can't do anything because it's linear. This line is straight. Okay? So if we were to graph this out, we're not going to. We know there's common difference here, common difference here. It's linear. If it's linear, there's no way for it to be quadratic. Yes?
So we don't practically graph if it's a linear line because that's...
This established this. When we see this ordered pair, we see no second common difference, and it's asking for a solution. That's what we're going to say. No. No, it's linear. And x and y have common differences. It cannot be quadratic. We're done. Okay?
I wish you gave us questions.
This guy.
That's
Okay.
simple.
Okay, what about the next one?
This is
Wait, number 4?
first one.
What's my a?
6. Negative 6. Or no. Oh, 6.
What's my b?
2.
What's my c?
1.
Okay. Do we know if this is quadratic or not?
Yes, it's quadratic.
Yeah, we know it's quadratic because it fits within the formula, right? Okay. Now, if you had this equation and you had to solve it, what would you do? How would you solve it?
Take 3
Put it in a table.
Very good. Let's go ahead and do it. I'm gonna erase this because we're gonna need room to solve this. This is kind of long. So x, we're gonna go -2, -1, 0, 1, and 2, right? And then our y is gonna be this: 6x2 minus 2x plus 1. Okay, put it in a table. Actually, let's not put it in a table yet because we're going to have some calculations to do, right? To figure out what our y is. Once we solve for this, we can figure out the y, right? So let's go ahead and put this in. 6, -2, 2, -2 in parentheses, plus 1. Any questions? All we did is just substitute the -2 inside of it, right? And then solved it.
It's -2.
-2, so that is +4 times 6, okay? And then I'm going to go ahead and take care of this right here. Isn't that +4? Plus 1, right?
And what?
Now we can solve it, right? What's 6 times 4?
24.
Plus 4? Plus 1? Okay, so we know our y, right? We know our x, we know our y. We keep going all the way down, and then we have the points to graph it out. Okay? Now, if we were to go graph this out, we could see where it turned. Do we know where it's going to turn before we even really look at it? What 3 points could we do that we could find the turn? Probably 0, right?
Yeah.
Because you have negatives, you go zeros, and you go positive. That's where the turn's going to be. And by the way, that's why you use the -1, -2, 0, 1, and 2. That's why you do that. Okay? All right. I think we should finish this one. What do you guys think?
Which one?
Yeah, I think we should finish this one. So I'm gonna go over here. I'm gonna write my x and y. Okay. So I know the first one is -2, and I know my y is 29. Right. So let's go ahead and do the next one. So we're gonna be.
Why -2?
I'm sorry.
X and Y.
Because remember, we're plugging in -2, -1, 1, and 2.
This one.
Yep. Okay, so let's do the next one. So we're going to be 6, -1, -1 to the power of 2, -2, -1, plus 1, right? So here that's going to be a +1 and 6. So this is going to be what? 6. What is this right here? -2, -1?
That's 2.
+2 plus 1, right? 9. So we know our second order pair, -1 and 9. Okay, let's do 0 now. 0,
Is zero?
not quite.
1.
Not quite. That's right, not quite. That's all 0. That's all 0, right? What's left over?
1.
1. So now we're 0, 1. Has it turned yet?
Yes.
Oh, we don't know that yet, actually. We don't have a deficit yet, right? We haven't went negative here. We're still positive. Okay, let's do 1 now. Okay, that's all 1 and 6, right? 6, negative 2, minus 1. What is that? Oh, by the way, how do I solve this? Why do you have to do it that way?
For operation.
Yes, left and right. Okay, 6 minus 2, 4. Minus 1 is what?
3.
Isn't it plus 1?
No.
Is it?
No.
No, I think it's plus 1. This is 1 times 6, 6. Negative 2, 1, negative 2, plus 1. Okay, order of operations?
5.
5. Good.
I knew.
Okay, so we're 1 and we're 5. So we have one more to do, right? Look at that. Now it's starting to move. It made the turn right there. Okay? All right, let's go do the last one. I'm gonna.
Erase the copy.
Yeah, I still need room. So. All right, so now we're gonna do 2, right? So 2, 6, 2, 2, minus 2, 2, plus 1. So 2 and 2, 4. 6 times 4, negative 4, plus 1. So 24, minus 4, plus 1.
21.
How much?
21.
Good. Okay, now we have our ordered pairs, right? So now our next step is, well, hang on, not yet. We're going to go check our common differences, aren't we? What does it take to get from 29 to 9?
Minus 20.
Very good. Minus 20. And what about 9 to 1?
8. Minus 8.
Okay, what about 1 to 5?
Plus 3. 4. Or plus 4.
Very good. And then 5 to 21?
Plus
Calculators.
16. Isn't it?
Okay, what does it take to get from 20 to 8? Negative 8.
What? Plus
Yes.
12. Yeah.
Yes. You have calculators?
Plus 12. I did it in my head.
Okay, then what about negative to 8 to 4? Positive 4.
Plus 4. No,
Plus what?
8.
And what about 4 to 16?
12.
Is this quadratic?
Yeah.
Why is it quadratic?
Because that has 30.
Second common difference, right? Okay, so if we were going to go graph this out, let's do it right here.
What if it's not quadratic?
You're done.
You're done?
But you know why you're done. You can explain it. There's no second common difference. Or there's no
So you don't
exponent of 2 on the x, or whatever.
So you don't graph
No, well, unless I tell you. No, sometimes you will graph it out because, like, if I ask you to graph this out, you're going to see it's clearly linear on the graph.
For like number 1, I did that. Not quadratic.
Number 1? Number 1 is quadratic.
You made it quadratic.
All right. So we're going to do, we're 29. So we're through 30 on the y, right? So we know it's going to be the upper half of the graph, right? So negative 1, negative 2, 1 and 2, that's all that we need. And then we're going to be clear up to 30, right? So let's do it in 5s. 5, 10, 15, 20, 25, and 30. Okay? Now we're going to go graph it out. So we're going to be negative 2 and 29. So negative 2, 29, that's going to be our first point. And then the next one's going to be negative 1 and 9. So it's going to be clear down here. Then the next one's going to be 0 and 1. So 0 and 1 right here. And then the next one's going to be 1 and 5. So 1 and 5. And then the last one, 2 and 21. So 2 and 21. We're going to go ahead and connect the dots up. So what is my vertex?
0 and 1.
Is it? Yes, very good. 0, 1. Now, oh, sorry. I mean, it's obvious which direction this goes, but let me put the arrows. Okay, so, am I minimum or maximum and why?
Minimum.
Minimum? Everyone agree? What is the minimum? What is it always?
It's 0 and 1.
Yes, very good. X, Y, it's going to be the Y. Minimum is 1. Let's talk about this for a minute, okay? Minimum of 1. Minimum of 1. The line is curving right here, right? It can't be anything greater than that. So that is the minimum it possibly can be. Everything up it could be, right? Good talk. Okay, so that's full circle, right? We were able to take an equation. We were able to plug in for our domain, right? We were able to graph it out and see it's quadratic. We were able to see it's quadratic from the actual formula, and then we did a table and common difference. That's all of it. That's what this whole section is, okay? You don't just tell me no, you tell me why it's no. It's linear. Linear line cannot be quadratic, right? It has to curve around. It has to have x to the power of 2. Okay? All right, let's get through these last ones. What is my vertex on number 5?
Hold on.
Are you going up by 5 or by
3, 1?
10?
Well, let's count.
3, 1.
1, 2, 3, and then what is my?
Negative 1.
What is it?
Negative.
Okay, so my vertex is -1 and 3, correct?
Mm-hmm.
Okay, so is this minimum or maximum?
Maximum.
Very good. And why is it maximum?
Because anything below is
Correct. And what is my maximum?
3.
Is there really any work here?
No.
There isn't. Okay, let's look at this one right here. 1, 2, 3, 4, 5.
5.
Okay? What is my, first of all, what's my vertex?
0, 5.
0, what type of 5?
Negative 5.
Very good. Okay?
Minimum.
Very good.
Negative
What?
5.
Very good. That's it. Okay, I have a question.
Yes.
What do we call the curve?
Vertex.
No, what do we call the curve? What do we call it? Come on, vocab people.
I don't know. Oh no, I remember. It starts with the name, huh?
No.
No. Oh, okay, no.
It's not the right thing.
No.
That's actual. Hey, what's the name?
Okay, you need to know this or everyone's...
What's the question again?
Every, all eyes on me. What do we call the turn in a vertex?
Oh, that was up there.
How about parabola?
Oh, yeah.
Okay? Do not forget that. You're going to need to tell me what that is. Okay? There's no math in the parabola, but the parabola is the turn in a quadratic equation, okay? Let me tell you why you need to know that. When you have something that's quadratic, you could use that, right? The parabola vertex is such and such. That tells me you know it's the turn, you know where the vertex is, you know where the maximum and minimum is. Are we clear?
Yes, sir.
Okay, is there any questions or anything I need to go over? Yes, Adrian.
Are there any going to be questions like number 5 and 6 in the test?
Pretty much, this is going to be a very good representation. You're going to have some that you just need to put in this form. You're going to have some that you're going to need to do tables, and you're going to have some that are full blown. You got to do everything. You got to put in the -2, -1, 0, 1, and 2. You're going to need to graph it out. You're going to need a common difference. You're going to need to tell me the vertex. You're going to need to tell me the minimum and maximum. And you know what I have to say about that? Welcome to high school. Look at where you came from where we started, right? Anna has a headache. Okay. So we are practicing tomorrow and Thursday, and the test is on Friday. Okay. Let's talk about the do now for a minute. This question right here, is it quadratic?
Yes, but you just don't have a C.
Well, you have a C, you actually don't have a B.
Oh, yeah.
okay? So